This is Sierra Albin for Physics 221, and this is my Chapter 7 reassessment. I first wanted to start out with an easy one just to show that I knew what the concepts were and what the units were. So on the first slide, we have potential energy for an ideal spring. U stands for potential energy, and we have an S here because it's for the spring. Ks stands for the stiffness of the spring, and S stands for the length the spring is stretched. So, the question that I'm working on asks how many joules of energy can you store when the spring stiffness is 0.6 Newton meters and the stretch is 20 centimeters. First, to do these kind of problems, knowing the units is important. So I've put out in front of us what joules were and what newtons were, so we know when we work out the problems if we end up with joules. Apparently this slide got a little messed up, but this slide is me converting 20 centimeters to meters because joules and newtons both have meters, not centimeters, but the length stretched was given to me in centimeters. Therefore, I have to do a dimensional analysis of centimeters to meters. Then on this slide, you have the equation worked out, and I've worked it out with the units actually not into like newtons and things, so I could see we're multiplying, and would come up with the N units. So we have our spring stiffness, which is 0.6 kilograms meters per second squared, and then we have our 0.2 meters, which was 20 centimeters. We plug this in and we get 0.024 kilograms meters squared per second squared. You take this number and you multiply it by a half, and you come up with 0.0112 joules. You get joules because kilograms meters squared per second squared is joules, and by multiplying the Ks, which is the spring stiffness, by the string length stretched, you multiply meters together, which you get meters squared, which comes down here to meters squared on the top, which leads to the joules. Thank you.